First off, to solve a formula for a specific variable, the first thing you want to do is indicate the variable to be isolated. And that's the catch. We want to isolate it. Now, as you see, I'm going to use highlighters. You can use whatever you wish. Then you have to note the operations that have been done to this variable of interest. Then the process to solve is to undo those operations in reverse order to isolate or get the variable we want by itself. Now we're going to do some easy ones, and then we're going to get into some more interesting ones. Now, the first one here says we have a formula. The formula happens to be I equals PRT. I equals PRT. Now notice there's no numbers here. Everything is letters. Well, that's what algebra is. It's a lot of letters. And it's learning how to move those letters in a proper way to get what we want. Well, it's going to tell us in this story what each letter, these 4 letters, represent. Now, it says the I represents simple interest. It then tells us that P is the principal, R is the interest rate, T is the time. Those are our 4 variables. Now, notice what they want us to do. They want us to solve this formula for P. Okay, you want to, in this case, indicate what variable we want to isolate. Well, we want to isolate P. That's step number 1. Now, P is connected with R and T. Well, when letters are next to each other, they represent multiplication. So therefore, we want to undo the multiplication that put P, R, and T together. So if multiply is what we did, then we are going to divide both sides by RT. Well, on the side that's got the letter P, these R's and these T's are going to cancel, leaving me with my P, which is what I want to solve for. And my answer is this fraction, I over RT. This is my answer. Right here, highlighted in yellow. Now, let's do a couple more. Okay, this one is saying solve for the indicated variable. Well, notice here the phrase for T. That means in the formula that has the capital D, the capital R, and the capital T, we want T by itself. Well, that means I've got to look and find out what operation put the R and the T together. Well, this one happened to be multiplication again. So what I'm going to do is divide both sides by the capital R. These R's are going to cancel out, which means that to find T, which is what I have all by itself, it is the fraction d divided by t. Okay, now this next one, notice that we want to solve for L. Well, before we can do that, we have got to get rid of and isolate the 2L first, which means we are going to subtract 2W from both sides. Well, this is going to cancel, leaving me with P minus 2W is equal to 2L. But notice, I want just a single L, which means I've now got to get rid of the 2. Well, to do that, I am now going to divide both sides by 2. Now, this is one way to write the answer. P minus 2W in the numerator. But also, you have to recognize that what's circled in red is 2 fractions. This can be P over 2 minus 2W divided by 2 is equal to L. But one thing that you've got to watch, because I have 2 fractions, this 2 and this 2 can be reduced, okay? Which means I can take these out, which means that L could also be equal to P over 2 minus just the W. It can be written like this, or like this. L can be written 2 different ways, one of which is breaking up the 2 fractions that I found in my first part of the problem above, or I can break it up into 2 small fractions. Now, I will let you know that Pearson sometimes likes this answer that I'm highlighting in yellow, but it also likes this answer that I'm highlighting in hot pink. You're going to have to look. Sometimes they're going to give you both, because you can solve this problem by getting 2 different answers, the one in orange and the one in pink. But 9 times out of 10, they're going to take the orange answer. Now, with that said, let's look at this one. Okay, now this one's going to be a little bit more of what we did in the last section. We want a single r, but notice this has an exponent. Remember in 3-9 we used radicals? Well, that's going to come into play, but not just yet. We still have to isolate the term that has r squared. So we are going to divide both sides by the root. Well, we are going to divide both sides by the root. Well, this will give me r squared is equal to the fraction a divided by pi. But because this has a little 2, remember, we are taking the root, which means that the single r, and I should probably write a better r than that, is r. Okay. This r should have been a lowercase r, leaving me with the lowercase r is equal to the square root of a divided by pi. This entire fraction is underneath the radical. Okay. The whole thing is underneath the radical. Now the same thing's going to happen with the next one. Notice that again we have an r2, but I want just r. Well, first off, I have to isolate that r squared, which means I'm dividing both sides by 4 pi. That means r squared is equal to the fraction of capital S over 4 pi. But I have to take the root of both sides to get an r, a single r, which means my answer is the fraction x over 4 pi underneath the radical. Now, the next slide sometimes is more difficult than you want it to be, but hopefully it won't be. Okay, first off, this is asking you to find r. And notice r's right there. Well, we have to get rid of this p plus in front of it, which means I am going to subtract p from both sides. Now notice I'm going to write it over here. A minus capital P is equal to P R T. Well, we still have to find this R, because that's what they're asking for. Well, what put the P and the R and the T together? Multiplication. Now that means I am going to divide by the capital P and the T because I want the R to stay. But over here, this is dividing by P and the small t. Now, this that I'm circling is a good answer. But remember, this is 2 fractions. And sometimes Pearson wants the fractions reduced, which means I would write A divided by capital P T minus in the middle. This is P divided by P over T. Now, notice this P and this P can be reduced. I can cancel them out, which means that this R can also equal A over P T minus 1 over T. This is another way to write my answer. So you have 2 ways to write your answer. It depends on which answer Pearson likes. Okay, well, here we go. This is a formula that they want us to convert from Celsius to Fahrenheit. Celsius is the C, Fahrenheit is the F. Now, rewrite. Now, they call it a new function, but it's another way of saying, give me a new equation that gives Celsius for the given Fahrenheit temperature. This is saying that I want to solve for C. Okay, well, notice where my C is. My C is right here. Well, first thing we're going to do is subtract 32 from both sides. This gives me 9/5 C. Now, here's the part you have to watch. 9/5 is a fraction. It's multiplying 9/5 is a fraction. It's multiplying C. But when I multiply by a fraction to get 9/5 C, I have to use the reciprocal because I'm dividing by 9/5, which means this term has got to multiply by the reciprocal. This quantity gets multiplied by the reciprocal. And as you see, this 9 and this 9, this 5 and this 5 cancel, leaving me with a C that I want. My answer is 5/9 in front of a parenthesis that has F minus 32. This blue is my answer to give Celsius for Fahrenheit. I just moved terms around. Now this problem formula has a number, but I have to know how to work with the number. Now here we go again. This is something you're going to find quite a bit, and they are now introducing you to this. If you're given the equation in standard form, now notice this says AX plus BY is equal to C. It is easy to identify the slope and the y-intercept if we solve for y. And remember, the slope represents the m. The b, the little b, represents the y-intercept. Now, I want to show you something about how we're going from here to here. We are going to subtract CA or CX, AX from C. So this will give me BY is equal to C minus AX. I am dividing both sides by the letter B. Now, this gives me y equals negative a over b x plus c over b. This negative ab is the slope. That's my slope. C over b is my y-intercept. This is a symbols game. We went from standard form to slope-intercept, but we have fractions in my final answer here. And I'm going to make that in orange. These fractions, negative a over b, is my slope. C over B is my y-intercept. That's that B. Symbols. Okay. Okay. And let's show you what I mean. This is an equation that is in standard form, right here. 4x minus 3y is equal to 12. Now, if we solve for y, this is going to give us a negative 3y is equal to a negative 4x plus 12. Divide by negative 3. Well, this will give me y is equal to a positive 4/3 x minus 4. Now, notice something. This 4 was my a. This negative 3 was my b. Now let's go back one slide. Remember I told you that the slope was a negative a divided by b, and our y-intercept was c over b? Well, notice right here. If I know that in standard form, my slope is equal to negative a over b, notice that this was my a, this was 4, my b was negative 3, and there's my negative sign. Notice what I got here, 4/3. And if I took my 12, which is c, this is c over b. Well, notice c over b, when I have numbers, is negative 4, which means my y-intercept was 0, negative 4, c over b. Now, we're going to use this equation because we're going to learn how to graph using the slope-intercept form. Now, you want to get to this equation in yellow. Okay, and let me show you why. We had y is equal to negative 4/3 x minus 4, and I think it was a positive 4/3. Yeah. Okay. 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 Now, how do we use this? Now, how do we use the slope-intercept form? Well, we begin right here with this negative 4. We find this point. Now remember, that point right here was my y-intercept point. Now, the fun part is the slope. Okay. Well, this yellow dot is going to take this first slope, which is a positive 4 over positive 3. From this yellow dot, I go up 4, right 3, because I have positive. I'm going in this direction. But I need to go also, because this took me up. Well, I want to go down also sometimes. Well, that means if this was a positive 4 and a negative 3, I am doing the opposite. Negative 4 over negative 3, but I am going from the yellow dot, which means I'm going down 4. And then I'm going left 3, which means I have this dot way down here. This slope is taking me down, but they all begin at the yellow dot. I have to go right, I have to go left, and they all go from the same spot. Okay. Now, we're going to do another one. Okay. Now, first off, they want me to use this equation, and they're telling me to solve it for y. Okay, this is 3y is equal to negative 6x plus 15. I'm dividing by 3. This gives me y is equal to negative 2x plus 5. This is my equation. Now my slope is a negative 2 over positive 1. But don't forget, my slope is also a positive 2 over negative 1. One is going to take me left or up. One is going to take me down or left. But where do I start? The y-intercept is 0, 5, which means my yellow dot is sitting right up here. Well, if I use this slope, I'm going from my yellow dot. I'm going down 2, right 1. That means I'm going in this direction. This is the first slope. But remember, I also have this slope from the yellow dot. I go up 2 and I go left 1, which means from the yellow dot, I'm going in this second direction. But they all go from my y-intercept. Now you're going to say, well, why can't I just use the green? Well, you have to remember that there are going to be times that you're going to have to go in either direction. If you'll notice, the blue point is off the graph. I need to make sure that I know that I'm correctly going and making a line properly. So therefore, I have to know how to use these two slopes. And all I'm doing is, if the numerator is negative, my other slope will have a positive and opposite signs of the numerator, but the denominator will also have opposite signs to allow me to properly graph. Now, this is a formula that you're going to be seeing, and there are two of them, one of which we've already talked about. This is the slope formula that we like to use. But now we're going to talk about not only standard form, slope-intercept form, we have what we call point-slope form. And notice we're using the x1, y1 point. Now notice this is how Pearson likes to do it. Occasionally, they also do it this way. But you will find that as we go forward, they're going to tell you whether to use this formula or this one. And they only do it in this section. Well, here we go. We are going to be told to write an equation in point-slope form. Well, again, notice we have the two equations. And we have this point. We have a slope. Okay. Well, here we go. Now notice the form they're asking you to use. That means that the 4 is my x1, the -5 is my y1. So that means I'm putting them x1, y1 in these two positions. And they tell me a slope. Well, this will give me y minus a -5 equals my slope of 6, y equals my slope of 6, x minus a +4. Well, I got to get rid of some of these extra parentheses. That means that these two negatives are going to give me y plus 5. This is going to give me 6, but don't forget, these two signs are going to give me x minus 4. This is my answer in point-slope form. Now, my last problem, okay? It is saying a point contains 2, 5 and a slope. Now, there are two ways to obtain this equation, which is true, okay? Now, they are going to want me to do the point-slope form on this side. And then notice what they're going to do. They want me to solve the equation for y to obtain the slope-intercept form. Okay. Now, point-slope form is kind of nice. We are going to have x1, y1. Here's my slope. Now, I am going to do y minus 5, and it's a positive 5, so I know a negative times a positive is going to give me 5 equals 3x minus a +4. 2. Well, a negative and a positive, I know. In my head, instead of writing y minus a positive 5 is equal to 3 parentheses x minus positive 2, I just knew that my negative times a positive that happens in these two places was going to give me that negative sign. Now, I want to go a little further with this. Okay. Okay. Now, slope-intercept form. Do you remember how that works? This is y is equal to mx plus b. When I use this form, notice I don't know b, but I do know everything else. I know that my y is 5, my slope is 3, my x is 2 plus b. Well, this is 5 equals negative 6 plus b. My b equals 11, which means my equation is y is equal to 3x plus 11. Huh? Oh, wait a minute. This is a positive 6, which means that this because this is 6, this will give me a negative 1. This is my equation in slope-intercept form. Now, I'm going to erase this line because that's why I showed you. I was trying to save space here just because I knew I was going to have to do a little more. Now, if you'll notice, these two equations at the moment do not look the same. But watch what I do. I am going to add 5, which gives me y is equal to 3 parentheses x minus 2 plus 5. Distribute 3x minus 6 plus 5. Notice what I get. Y is equal to 3x minus 1. Notice that these two are the same. One used point-slope form. That was the yellow side. The orange side used slope-intercept form. They are the same equation. It's just we had to do a little manipulation with the point-slope form to look like the slope-intercept form. We're solving for y if we have to graph. If we want slope-intercept form, we're solving for y. Now this should end 3:10. Hope you enjoy it.